just the way it's going to be. So just a quick show of hands, how many people in here know that NOAA has an R&D program specific to pit tag? Okay, so pretty much everybody. So I wanted to get this talk because I felt like we sort of developed our ideas for what we're going to do for R&D in sort of this nebulous little group. Right now, it's only Gordon Axel and myself that are doing the R&D project. But it's been a 35-year project. We get a lot of direction from BTA on what needs to happen for the R&D. But I feel like this is a great opportunity to reach out and ask the community, is there some place where we need to focus our funding? Some of the stuff that Andrew brought up yesterday when we started looking at all the failures on the stream side. I mean, that seems like something we should be able to address and fix going forward. So what I wanted to do today is just sort of give you a broad outline of what we've done in the past, what we're currently doing, and the things we're thinking in the short term, but then make this more of a conversation where you guys have my contact information. And if we sit down with another survey and formally decide that, yes, the power systems on the shore are a big reason why we lose data, then we can focus some attention on that. So what we've done in the past, there was somebody had a slide yesterday, and like we just keep hearing about Earl Prentice. So there's a picture of Earl with a sledgehammer in the stream because we used to anchor in antennas to stick the rebar. And he brought pit tags to fisheries back around 1980. Heard a TV show or a radio show on his way home from work where they were using RFID tags in horses because they were getting stolen. And it's like, can we use these in fish? And that was the start of pit tags in fisheries. Mm-hmm. So from that point, you know, he worked on the adult reader. From that, the MUX was built. I mean, these have been funded through Bonneville Power Administration, some of it, and in-kind development with Desk Frontier and Digital Angel and now Biomark. But I mean, these are the things we've brought to NOAA R&D program has brought to fisheries. From helping to develop the Bonneville corner collector to Earl tested a whole bunch of different power systems and decided that thermoelectric generators were a really reliable quiet power source, so that's why we use those now. My first project when I came into NOAA was working on the master controller in IS 1001. And what the model that we've sort of adopted is we build this statement of need and we submit it off to, at this point, it's Biomark and say, well, this is what we need the reader system to be able to do. But we've always just done that in-house. And what I'd like to do is establish some sort of communication with everybody here to say, we really think this should be a point of focus for NOAA. And we're currently working on a system that will use the FS3001 OG transceiver, which I'll talk about in a minute. But we've also broadly helped the community in things like the Canadian Navy noise, or when we had noise 2 years ago down in Dayton, California, and things like the HAP telegram tag that we may need in the future. And if I talk about anything and you have a question, you can stop me during the middle of this talk. So what we're working on this year, and have been for several years, our primary focus has been the Lower Granite Dam Spillway detection. We're also looking at ways to improve Bonneville detection to get the overall detection up to about 30%. The CAN bus issue that I talked about yesterday, anybody that's installed one in-stream has probably experienced some issues with the CAN bus coupling. And so we're working on that. The flexible antenna design that I talked about yesterday. We're looking at alternative methods of communications with the site, and I'm also working on an inexpensive switcher because I received a call from Earl a few weeks ago saying, who sells this 12-volt switcher? And turns out no one does at this point, so I started to put one together. But we sort of have that flexibility that if there's a need, we can kind of jump on it. So the Lower Granite system, we're looking at installing detection into the spillway, which presents some challenges. Primary of which being 75 feet per second the fish are traveling. So if you can imagine shooting past this room in 1 second, and we're trying to decode that tag code over the flat plate antenna. So what's happening in that spillway is they're going to trim out a little bit of the concrete, and we're going to place antennas onto the OG and then pour concrete over top of them, and hope they work forever. So initially, what we came up with ice harbor dams. I mean, this goes back to where is Don? It was like 2010.
Yeah,
when we looked at it, so
we started talking about it.
A lot of fish don't go through the juvenile bypass facilities when they pass the main stem dam. So we need some way to detect them as they spill. So originally we looked at Bonneville placing an antenna on the backside of one of the gates. And then we talked to the Corps Ice Harbor Dam. We would cut 3 large notches in the ocean face that would be 6 feet deep and 5 feet wide. And the Corps was like, wait, those dams are pretty good. We don't need to be cutting big holes in them. So now we have an opportunity to actually go in while they're removing some concrete and modifying the angle of the OG and the slip lip and to place antennas in there. So we work closely with Biomark and Biomark engineers to develop a flat plate antenna that doesn't have the same read issues that an in-stream flat plate pipe antenna where you have a place where you read and then a dead spot and then a place where you read. You need to come up with an antenna that would fit under this lift and have a zone of detection from front to back that can handle the 75 feet per second. So this is the antenna that will be poured into concrete. It will be entirely covered with 6 inches of non-ferrous concrete, with the exception of the components that will likely fail in the future, which are the capacitors. We'll also be able to adjust them after they've been installed and a place to access the grounding points to the shield. So we've done an awful lot of testing. I mean, we worked with Biomark to develop the reader from scratch. Basically, it's built off of the IS 1001 structure, but it's far more powerful. We can push almost 45 amps to an antenna versus the 10 amps that you can push on the IS 1001. And what that has allowed us to do is to take a flat plate antenna like that and read 52 inches above it. So that'll be 4 feet once it's underneath the 6 inches of concrete. And this is the read field, so it's solid from front to back. However, even at 75, it's a large read field, but at 75 feet per second, we're only going to get a single telegram. So 31.5 milliseconds to detect that tag code. We have just enough space over top of that antenna to detect it. So I mentioned we're also looking at the half telegram tags we may end up having to use if it turns out that there's a lot of tag collision or there's enough noise that we're simply not picking up the full telegram tag. So we sort of have that in our back pocket. That development of the half telegram tag is not fully, there's no specifications currently. We've tested it, we know it works. Any system out there, master controller with an IS 1001 or the 3001 can decode a half telegram tag, but we don't have a clear specification because we don't know if we're going to use it yet. So this is what it's going to look like. It gets poured under concrete. We'll have 10 full antennas and then an 11 split antenna in the middle that sort of covers the gap of the expansion joint. And yeah, 6 inches, roughly 6 inches of concrete will be over top of all of that forever. One of the other things we're looking at, and we've worked very closely with Don's group, is to develop ideas for adding detection at Bonneville. So this is the ice and trash sluiceway at Bonneville. There are two bays that are fixed that spill between 6 and 8 feet of water, and we're looking at suspending floating antennas above and IS 1001 driven antennas on the bottom and getting most of that read field there. And then a couple of gates that we've looked at are adjustable, so we would cap those with IS 1001 antennas. They'd have about 24 inches of water spilling over top of them. They'd have to be very tough because this is the ice and trash sluiceway, so there's a lot of trees and ice and trash that go over this. But it's a year-round passage route through Bonneville, so that would answer some of the questions about fish moving at different times of the year. A second idea to boost the detection would be to add a secondary Bonneville corner collector antenna in the BCC channel. Currently, accounting for the 9mm tags, we see roughly 80% of it. We detect 80% of the tags that travel down the channel. If we added a second antenna, we could get close to 100%, which would boost Bonneville's detections overall by about 3 to 5%. that's a 7-figure project. So we're sort of trying to balance that. And so the third approach we're looking at is as in-river detection downstream of Bonneville, somewhere outside of the boat restriction zone by the JBS outfall pipes. So one thing that we tested this spring was West Fork Environmental fin barge down to Lower Columbia. We were primarily testing what it took to assemble and then install on the main stem Columbia River, which included developing an anchoring system that would hold it out in the Columbia, and to look at what the maintenance requirements would be. It worked really well. The anchoring system we think we have pretty well nailed down. However, as was mentioned yesterday, with debris, if debris comes up against these fins and pops them free, that requires someone to go out there, and he or she has to reattach the fin and ratchet it back up. We're thinking if this is going to go below Bonneville, that we'll probably have to automate that system where either it will shed its own debris or it will reset once it has it's free. And I spoke about this yesterday, but one of the other projects we're looking at this year that will hopefully benefit everyone here that has master controllers and IS 1001 is sort of fixing that coupling issue on the CAN bus cable. We're always looking at ways to improve in-stream detection, which is the conversation that I want to have with everyone here. That if you have an idea that you think, this would really solve a lot of our problems if we could come up with something other than wireless communications to the antennas, then please approach us and we'll see what we can do. So one of the things I wanted to touch on is how we collect the data from our site, the NOAA site. So it's very simple. I have a computer in my house. It's a picture of me and my computer connected with the internet, and we only have the modem. So this will dovetail into John's work, where we just call into the site with power source and the modem, and we download the data, and then we email it out to researchers every morning. But what we'll end up doing is to massage that into the JSON file and then push that up to tag. But our server is a lot like what Derek presented yesterday, where it has just a Python script that every morning will dial into a site and pull back the status report, do a buffer download, and if it's selected for that day to do a buffer erase, it will do that. It goes through the download file to make sure there are no errors in the tag code or the data, and if there are, it won't erase that. It will simply send out what it got and tell you that it had an error, so you may have to reset the reader. And then it generates this Excel spreadsheet that sort of gives you a breakdown of your virtual tags, any real tags. It'll tell you what the real tags are. And then you have all these tabs where you can go in and look at what the master controller looked like yesterday, its status, its input power and temperature, and then you have a status report for the nodes, which will give you just a quick look at what you had yesterday. The downside to this is there are no alerts. This requires researchers to actually get in there and look at their data every day to make sure these data are what you would expect at that site. One of the other things we're looking at is possible inexpensive satellite communications. So this little module here for $220. It is a Iridium satellite, but instead of paying for a monthly plan, you essentially buy credits, and it would be possible to have a data logger in a site that would only really give you a thumbs up or thumbs down on that day to say this site's been working for all 24 hours or no, you need to come out here. And it could also send back 2 tag codes for 5 cents. Does this make sense? I don't know. We're looking at it. I'd like to get some feedback. If this does sound like anything people would be interested in, or if it's not going to save enough money, then we certainly won't proceed with any of its development, because like I said, it's really only me and Gordon Axel. But we would have to develop a data logger or work with BioMark to develop a data logger that could do some serious data compression and really whittle down what it is that we really want to see. Is it just antenna current, or is it got 24 timer tags over 24 hours, so I know that antenna's good. And then, like I mentioned, we have the agility, flexibility. So when someone picks the phone and says, hey, I really need a 12-volt switcher, I can sit down and I think 2 weeks ago I laid out a board and populated it. So there's a prototype to see if I can get it to work. But I would like to extend that offer to the community and say, if there's something that you think we need to work on, we have this budget that's happened every year for 35 years to work on pit tag related work. I guess most of the focus recently has been on the Lower Granite Dam, but after next year, we'll have an opportunity to hopefully proceed with whatever we determine is the most feasible application at Bonneville for increased protection. If we need that have telegram tag, we will finalize the specifications for that. We'll continue to work with Tagus on the M5 platform if it ends up needing to have a hardware solution in the box to talk with the water quality monitors or whatever you have in there, and then anything else we can do to lower the cost for in-stream detection. With that, does anybody have anything that has, they thought about, oh, what we could really use? I mean, I think with a second polling of the group, if we can really tease out where our data gaps are coming from, if it is, antennas failing or if it is power systems failing, I think that'll help sort of direct us. But is there anybody out there right now on the phone or in the crowd that has something that they thought, wow, we could really use this?
So my two biggest problems at site are both power related. One of them is the batteries get deep charged for an extended period of time, and then the relay on the battery switchers don't have the power to switch it back. And so I have to go out to the site and physically switch it. So if we had instead a charger or an inline connector that might have a high pass or low pass filter on it, power filter, that charged batteries, has a battery backup, but use the main source of power. I think that would solve that problem. The other problem I see most of the time is that either the CAN bus cable goes bad, gets a short in it, and that shuts off the master controller, or the node flush, and that shuts off the master controller. So if we had trunks from each of the nodes coming in that had some sort of power switch or fuse on it, where it would just shut off the single node and not the whole system. Right. Those are my two hangups that I've got.
Have you used the DOP?
But I haven't.
I mean, we were disappointed with the CAN bus as a solution when we got the master controller back. I mean, when we did the development, it became evident that the way to maximize read range at the antenna is to put the reader at the antenna, because in the MUX site, all of that antenna cable that's going out there is your antenna as well as what's in the screen. So back in 2010, 2009, when we developed this statement of need for a new reader system, it became evident that we needed to put the electronics out there. When the solution came back with CAN bus in a series of readers, we were definitely disappointed, but we've had to work with that. There is a solution that is the data over power, where you can push a wire out to each of your nodes, and then you won't have a catastrophic failure if you lose one cable. So there is a solution out there for that.
But if you still get a short in your power, you're gonna still
fuse each run. So it does fix that solution. The downside is, I mean, imagine a site now with 12 cables running back up the shore, and you have to protect that. It's a lot harder to do than, one or two CAN bus cables coming back. So I mean, there are pros and cons to it. I absolutely hear you on that and agree with why there's the DOT solution now. So, but to speak to your first question about, essentially a quiet UPS that would be there charging batteries and running the site. And we talked about this a little bit yesterday, that can work in a lot of instances where the AC power line is quiet and you can plug in a linear power supply. And if you dial that to the float voltage of a 12-volt battery or a 24-volt battery bank, and then you plug the battery bank in line with your system, that would essentially do that. Your linear power supply is not a good battery charger, but it will bring those batteries up once the power comes back. However, there are a lot of instances where you'll plug into AC power and there'll be a variable frequency drive down the way. So then you could add an isolation transformer in front of that to decouple from that AC noise, but then you're back to that's far more expensive than a switcher. And should we focus our efforts on an absolutely bomb-proof switcher with a low voltage disconnect to save those batteries so that you don't get in the situation when the power comes back on, that charger has to hit, you know, a 24-volt bank sitting at 12 volts. So, but this is the sort of stuff that I would like to, you know, get feedback. People, you know, send me emails or, you know, give me a call and let me know, hey, I'm thinking this would really help us out.